Hello, photostability and in liquids and solid state media. Optics Communication 2002 paper. Aim is enhancing photostability of laser dyes by the use of various quenching additives and liquid hosts, finding which photodegradation mechanism is more active in these two phases, solid and liquid. So, photostability of P567 in liquid and solid, deoxygenated, non-polar, and polar, and same in the polymer we have discussed. Introduction: solid state dye laser, tunable, compact, maintenance free, cost effective, and the property of this one is that dye should have large absorption band, high conversion efficiency, water soluble, and high uh, stability. Photostability is given by the gigamole gigajoule per mole. Total energy absorbed by the 1 mole of the laser dye molecule before the output energy is decreased to one half. Photostability is the affected by the formation of free radical or activate the triplet states in the dye molecule. More triplet states mean uh, decay of effect of dye molecules, so low photostability by the increased triplet states. Less triplet states, high photostability. So solvent, there are two kind of solvent: polar solvent and non-polar solvent. Some are more polar, some are less polar. Benzene is more polar, ethanol is less polar, and less polar, high dipole moment. So less polar, less photostability, high dipole moment. So less polar, high dipole moment. So less polar, high dipole moment, less photostability. More polar, high photostability, low dipole moment. So dipole moment to stability is the link. So this is photostability and dipole moment. So high, this is low. More polar, lowered dipole moment. So this is more polar. So this is the polar, non-polar, more, less polar. Uh, so this is low stability, high stability. So more polar, low stability. So more polar, so more polar, low stability. So non-polar, high stability. That's very good. Aprosity, aprosity is availability of proton, whether anion and cation can be dissolved more strongly in laser dyes. Protic, aprotic, active polar molecule, inert polar molecule. So THF, tetrahydrofuran, so low laser efficiency. On other hand, the non-polar is water and alcohol, the highest laser efficiency. Aprosity, aprosity increase or decrease the reaction of the kinetics, increase the strength of the nucleophilics, or decrease the strength of the electrophilic. So this is water on one end and dioxin on other end, and this is their dipole moment. So low and high. So this is a laser efficiency is high to 0, and photostability is high to 0. So this is the dipole moment. So as the dipole moment is higher, photostability is lower. Large increase in photostability by binary azeotrope mixture. Mixture was the azeotrope mixture of two or more liquid that uh, boils at constant temperature at a given pressure, shows the same concentration and composition in. This is water, this is propanol, this is zero concentration of water, this is 100% concentration of the water. And this is the water concentration increase, propanol is decreased. This is the vapor composition, and this is water, pure water. This is pure propanol, and this is the azeotrope. This is more propanol, and this is more water, and this is the graph. So negative isotrope, positive isotrope, boiling point of the mixture is more than the constituents. So the positive azeotrope, the boiling point of the mixture is less than the constituent. So these are the because of the uh, Raoult's law, the equality of the composition in a liquid and a vapor phase and the vapor liquid phase. Dalton laws, the equality of the pressure of a total pressure equal to the sum of the partial pressures. So ethanol 100%, heptone 100%. In between this one at this concentration, what is happening? So photostability is a 20 of ethanol, 50 of heptone, but 50 or 70. But in between this one, the concentration where this heptone is at 16%, dioxin is this one. Oh, this one, ethanol and heptone, this is the 20, this is 50, in between is 75, is a higher. Heptone and dioxin, at the start, it is uh, uh, 50, here is 70, in between is 1000 gigamole per per. So this is also the effect of this one. Quenching effect, uh, TMP, TPA, DEPCO, COT. We have seen this one in ethanol and TMP. Uh, different concentration of ethanol to TMP. This is the photostability 20 to 50. 50. Ethanol to TPA, it is more is here at 46. Ethanol to toluene, so this is the best result is the 30 to 60 to doubling, and then the ethanol to cot, this is 24 to 12, so this is the 40. This is the good result. So similarly, photostability of P567 and PMMA and the host, the solid material PMMA and TPA is added to 5%, 10%, 20% with the concentration dye is 10 to 3.3, 10 per minus 4 molar. So this is 0 TPA. So this 50, 95, 140, and 100, and this is the good result. A PMA and TMP, so this is the good result 140. So PMMA in toluene, so 145, good result. Then PMMA in DAPCO 190, which is good result. So PMMA in COT, which is this is 80, this is good result. So summary, photostability of the solvent, excuse me, 567 laser dye high photostability. So deoxygenated is 100 gigajoule per mole, and deoxygenated non-polar is 1000. So deoxygenated polar, deoxygenated non-polar 1000, 10 times more. Azeotrope mixture, so heptane, deoxygenated dioxin, 100% increase, 50 gigajoule per mole to 100% heptane, 100% dioxin, 50 gigajoule mole to 1000 gigajoule mole when they are mixed to azeotrope. So it is 19% efficiency is 81% per efficiency, and the photostability is 1000. So 50 individually, 70 individually, and the combined result is 1000 gigajoule. Azeotrope mixture can reduce the formation of free radical and triplet state, both contributing to the photostability degradation. So number three result is ethanol deoxygenated 20 gigajoule per mole, ethanol deoxygenated oxygenated 20, deoxygenated to 100. So reduction in oxygen also reduces the production of free radical. Number four, triplet quenching agent. Ethanol, 20 gigajoule per mole in solvent in different quenching agents. So from 20 to 60, 50, 40, 48, and this one is the good result is tenovin, which is three time increase. In solid, PMMA 50 gigajoule mole solid in tenovin, TMP, TPA, DEPCO, and this one's the best result is DEPCO, which is 190 gigajoule mole. So most result is tenovin in solid, least is TPA. In the PMMA, most is DEPCO, least is COT. So singlet oxygen quenching in DEPCO, oxygen TPA, TMP, TPA, tenovin. So it depend upon the diffusion constant in the polymer. So it is a higher photostability, lower photostability, reduced diffusion constant, increased diffusion constant. So additive must have higher efficiency. Lower additive must have a lower concentration. So lower concentration, higher additive have a lower concentration than have higher efficiency. So laser dye, high concentration, high lower efficiency. High concentration, lower higher concentration, high low quenching. Higher concentration, lower efficiency. Lower concentration, higher efficiency. So photostability of P567 laser dye, liquid, deoxygenated, polar, non-polar, as your top three things we have seen this one, in solid with the triplet quenching, TPA, TPA, TMP, tenuate, DEPCO, and COT. So these additives reduce the diffusion constant, reduce the photo production of free radical and triplet states. These radical and triplet states causes the photodegradation and the laser dyes of the P567. So this is the result. We have observed this one, and we have achieved the highest photostable liquid and solids.